Planet Earth, it is our home. It supplies everything we need, starting with the energy we use, be it from fossil fuels, uranium, hydropower, solar, or wind. The Earth also provides us with stone, sand, and gravel, and metals used in our buildings, and in our roads and on our bridges. Minerals are used in most everyday products, from paint, ceramics, and construction materials to detergents and medicines. We mine what are known as critical elements for use in modern technologies, from smartphones to wind turbines and solar panels. The rocks on our planet are also the parent materials of soil, which in turn supports plant life, including the crops we depend upon for food. But the Earth is a complex system with many interacting parts, including the solid Earth, the hydrosphere, atmosphere, and biosphere. A change in one part causes responses in others. For example, one effect of volcanic eruptions is to introduce gases into the air. The oceans absorb some of this gas, which in turn affects ocean chemistry and the plants and animals that live here. People are change agents too, and our sustainable future here on Earth depends on the wise use of resources provided by solid Earth. In order to understand how to maintain a sustainable future on this planet, we need to know how the Earth works. That in turn means we need a new generation of smart geoscientists. Some of those are pictured here, graduate students in geology and geophysics at the University of Wyoming. I'm Carol Frost, Professor Emerita of Geology and Geophysics here at UW. When I arrived in Laramie, Wyoming more than 38 years ago as a new faculty member, I could hardly believe my good fortune, for there is no place better than to study the geosciences than here. Over the years, I've been so gratified to have students return and say how they learned so much as geology majors and how their careers were jump-started with the knowledge and skills they acquired here. These students graduated with the ability to interpret the landscape and to understand the connections between people and place. In short, they learned to read the rocks from an expert faculty in a place where you can see the rocks all around you, right here in Wyoming. Wyoming is home to some spectacular geologic scenery. Who isn't impressed by Wyoming's geysers, or the majesty of the Teton or Wind River ranges, or the unexpected columns of rocks composing Devil's Tower? But interesting geology is not limited to these tourist attractions. Almost any travels in Wyoming take you to places with geologic lessons, not just for UW geology majors, but for all of us. Today, I'll try to convince you that by taking you back in time to 1905, when a young school teacher set out for her new job teaching children in a remote part of central Wyoming. She got there by stagecoach, and the route she traveled was neither considered particularly scenic nor designed to provide lessons in geology. Recently, a group of undergraduates and I retraced her steps, and we learned a lot. I'll share some of these geology lessons with you, and I hope you'll come away with an increased appreciation for this landscape, as I did. Ethel Waxham, a recent graduate of Wellesley College, agreed to teach 7 pupils, all in different grades, in a one-room log schoolhouse for $50 a month, nearly half of which she then paid back in room and board. To get there required a stage ride of 120 miles from the nearest train station in Rawlins, Wyoming, shown as the yellow line on the satellite image of Wyoming below, and the orange line on the 1896 map of stage routes at right. She took a train from Rawlins from Denver that traveled through Laramie, but when she passed, it would have been too dark to see the buildings of the University of Wyoming, even if she had known where to look. Arriving at the Rawlins train depot in the late evening, she spent the night at the Ferris Hotel, now sadly demolished. Then she got on the 2-horse stage the next morning. I'll be quoting from the journal she kept along the way. So did John McPhee in his book about Wyoming geology, written in 1986, called Rising from the Plains. I'll share some of his wonderful prose with you too. Why was Rawlins settled? Because of water. The coal-fired steam trains of the day heated water to turn it to steam. The steam then moved pistons connected to rods that run the locomotive's wheels. Steam locomotives needed to stop every 100 miles or so to replenish water, which is why the towns along southern Wyoming are spaced about 100 miles apart. Going west, Rawlins was the last place where water was available at Rawlins Springs. The springs emerge at the surface near exposures of the Cambrian Flathead Formation, which you can see in the distance behind the roundhouse in this photo from around 1910. Now let's travel north from Rawlins with Miss Waxham. She rode on a 2-horse stagecoach like this one. As she described it, with oysters and grapes and eggs stored away in boxes under the seats, and the goods and passengers enclosed in a canvas top and canvas curtains that flapped away at the sides. The travelers went past houses and sheepfolds, the cemetery, and the state penitentiary. Just north of town, travelers passed the Rawlins paint mines. The mineral hematite, which occurs here in the 500 million year old Flathead Formation, probably was used as red pigment by indigenous people. Starting in 1870, the red rock was mined for flux and as pigment for paint, known as Rawlins Red. This paint was used on Union Pacific rail cars and on the new Brooklyn Bridge in New York City. We continue north on Highway 287, which occupies the route of the old stage track. As Ethel recorded, mountains were far ahead of us, a range rising from the plains and sinking down again into them. John McPhee comments, in one sentence, Miss Waxham had intuitively written their geologic history, for they had indeed come out of the plains, and into the plains had in various ways returned. We'll see this for ourselves 14 miles farther north of Rawlins when we descend rather steeply in the Bell Springs area. You see, the Rocky Mountains came up during an event called the Laramide Orogeny, when tectonic forces compressed North America east to west. Blocks of crust were thrust up, forming mountains that geologists refer to as uplifts. The Rawlins uplift, shown on the map in peach and pink colors, runs nearly north-south, bounded by a thrust fault on the west side, shown as a black line with teeth. The motion of the rock on the east side, moving up this fault, tips the layers of sedimentary rock on top, so they're dipping down to the east, as shown on the block diagram on the right. At the north end of the Rawlins uplift, the highway crosses the Bell Springs Fault and runs downhill off the uplift to Separation Flats beyond. We'll stop at the bottom and have a look back. Just like Miss Waxham, when we stop, turn around, and look south to where we just were, we see 175 million years of geologic history. I've labeled and color-coded our topographic and geologic staircase with the ages of the rock layers that have been tipped up by the motion of the block of crust along the thrust fault at the far right end of the hillside. Now we head north across Separation Flats into the Great Divide Basin. It is a desolate place now, just as it was in 1905. Miss Waxham's stage pulled into Bull Springs, and she hurried into the station, chilled through. It was late October. When my students and I made the trip in April, it was chilly too. The Great Divide Basin, outlined in black and labeled GDP on the map, is a large, internally drained topographic depression, a basin where water never leaves. Ephemeral streams flow into large playas or small lakes or disappear beneath aeolian sand dunes. The basin is arid with low precipitation, only 5 to 12 inches a year, and high evaporation rates from the shallow lakes of more than 30 inches a year. It's a windy place. The Great Divide Basin lies within Wyoming's primary wind corridor. Dune fields trend from west to east, parallel to the prevailing wind. Winds blow on average at 15 miles per hour in the summer and 23 miles per hour in the winter. These sand dune fields have been active for over 7,500 years. Studies of the entire thickness of the dunes indicates that the wind intensity and the direction have not varied much since the last ice age. The wind that created the Great Divide dune fields and made conditions difficult along the Rawlins-Fort Washakie stage route now provides a renewable energy resource. In 2021, 423 wind turbines with a total rated capacity of 736 megawatts are located downwind to the east of the Great Divide Basin, and more are being installed each year. The next stop, 16 miles farther across the Great Divide Basin, is Lost Soldier. Here, Miss Waxham's stagecoach gets a new driver, Al Peggy Doherty. Peggy had gotten caught in a blizzard in 1883 while driving a stagecoach between Green River and South Pass, Wyoming. By the time he reached help, his extremities were frozen and he had lost fingers on both hands. He'd lost one entire foot and part of another. That did not stop Peggy. He continued to drive stages on the Rawlins to Lander stage route until 1906. "Ye gods, how he could swear," commented Miss Waxham. At Lost Soldier, we encounter another aspect of Wyoming's geology, its oil and gas fields. When Miss Waxham passed through, notes McPhee, she had no idea that the sediments 2,000 and 3,000 feet below her contained prolific traps of oil and gas. Nobody knew that. Discovery was a decade away. The domal structures that trap the oil, according to a UW geology professor who said this back in 1948, are so beautifully exposed as to be recognizable by most anyone with even an elementary understanding of geology. These structures are called shephherder anticlines because they are so obvious that even a shephherder should be able to recognize them. In the last 50 years, oil production has declined, as shown by this graph. You'll note a couple of jumps in production, though. These were due to advances in oil recovery through new technologies and advancements. The first was in the late 1970s when producers learned to inject water to help push the remaining oil towards the production well. And the second was in the late 80s when CO2 injection enhanced recovery. Next, we head to Crook's Gap. It was nighttime when Ethel Waxham arrived and the stars were out. As McPhee wrote, "The bright starlight fell on the fields of giant boulders, black and silver in relief. The big boulders were granite and the smaller were jade." There are no areas high that are nearby with granite and jade in them in the vicinity today. So how had these boulders gotten there? Jade was first reported in this area in the 1930s, and hunting for jade in central Wyoming became very popular in the 1940s. There isn't much to be found now, certainly no boulders as large as the one shown in the photo on the lower right. Wyoming jade, which is composed of the mineral nephrite, was adopted as Wyoming's official gemstone in 1967. But there are other treasures at Crook's Gap. McPhee writes, "There was uranium in Crook's Gap in great quantity. It would be discovered in 1955. There was petroleum under Crook's Gap too. The year of discovery would be 1925. Above the gap was Crook's Mountain." Miss Waxham might well have wondered who the eponymous Crook was. Uranium surface mining began in 1956. You can see the McIntosh and Big Eagle pits on the lower right of the satellite image. The town of Jeffrey City up at the top of the map, along Highway 287, was built to house the mine workers. Wyoming production peaked in 1980 when Jeffrey City's population reached 4,000. Surface mining at Crook's Gap ceased in 1989, and today Jeffrey City is essentially a ghost town. Both the McIntosh and Big Eagle pits have undergone significant reclamation. Now uranium production continues 15 miles south of Crook's Gap at a place called Lost Creek. Uranium is extracted in situ by injecting oxidized fluid that dissolves the uranium. The solution is pumped out and the ore is extracted. Oil was discovered in Crook's Gap and at nearby Sheep Mountain in the 1920s and 30s. Despite their proximity, the oil fields tap different reservoirs. The Sheep Creek field produces from the Permian Phosphoria Formation, and the Crook's Gap field produces from younger Cretaceous rocks. Production is modest, but it continues to the present as shown on the graph. Our route now takes us north, and ahead is the Sweetwater River, flowing gently east-west amid the low hills of the Granite Mountains. This high, shallow valley offered easy passage to the pioneers on the Oregon, California, and Mormon trails, and the stagecoach route now turns west to follow the same path. McPhee asks, the Granite Mountains were once as high as the Wind Rivers. How did they go down? Why did they go down? The answer also explains the strange appearance of the large granite and jade boulders in Crook's Gap. Let's look at the geologic map of the Granite Mountains. The blue line is our route from Rawlins to Haley. We just drove north from Crook's Gap into the high valley with the Granite Mountains sticking their tops out of the sediment fill. Notice the two red lines. Those are the faults that are the clue to why the Granite Mountains are so low and unassuming. If we look at a north-south cross-section of the Granite Mountains during the Laramide orogeny, when all of Wyoming's mountains were formed and thrust high into the sky, we'd see the Granite Mountains looked no different. These high mountains would have started to erode, shedding blocks of rock to the north and to the south, including the boulders of granite and jade. That's when the boulders at Crook's Gap got there, when the Granite Mountains were high peaks. But then something happened. New faults broke through, indicated by the red dashed lines on the cross-section. The tall Granite Mountains in the middle dropped down, forming a deep valley, leaving the foothills of the mountains on the north and the south higher than the peaks in the middle. Do you know who described this process and drew the figure on the bottom? It was Ethel Waxham's son, geologist David Love. The road is level and the driving is easy as we go west, but there is excitement ahead, especially in a stagecoach. Miss Waxham has been hearing about Beaver Divide since she boarded the coach. The road drops very steeply, and in the stagecoach days, the area was strewn with wreckage and with the bones of horses. Miss Waxham wrote in her journal, "The driver rough-locked the back wheels," that's to keep them from turning, "and we started down. It was a scramble for the horses to keep out of the way. There were sudden turns in the road, and the furrows cut by the freight wagons almost through the careening stage on its side. One of the horses fell, but it was dragged along by the others until it finally regained its feet. The coach swung from side to side in the gullies." The old road follows the base of the hills in the photo. The sedimentary rocks on the skyline are the flat-lying rocks that filled in the valley created when the Granite Mountains sunk down. Farther down the hill, you see rocks that are dipping below the flat-lying rocks on the skyline. These are older rocks that are part of the crustal block that was tilted up during the uplift of the Wind River Range. But there's something else very interesting about Beaver Divide. It's so called because it is a drainage divide. McPhee explains, "The Beaver Divide separates waters that flow east into the Platte from waters that flow north into the Wind, Bighorn, and Yellowstone rivers." This map of Wyoming shows the drainage basins. The Sweetwater River drains east into the Platte River. It passes very close to Beaver Divide as it meanders across the high, flat-lying sedimentary rocks of the Granite Mountains. Haley, Wyoming is located on Beaver Creek, which drains north to the Wind River and the Bighorn River. These rivers have eroded downwards and now lie at much lower elevation than the Sweetwater River, as shown by the panorama view to the north from Beaver Divide. What will happen in the future when the Beaver Creek excavates more sediment from its headwaters? The precarious divide between the two drainages may be breached, and the Sweetwater River will reverse direction and cascade down over Beaver Divide into the Bighorn River Basin. That would be something to see, but thankfully it is not on our agenda today. Our trip down off Beaver Divide brings us to Haley, Wyoming. Miss Waxham's stagecoach arrived there too. You see the Haley Hotel and Roadhouse in this photo, where the head of the family she was to board with while she taught school picked her up and took her the remaining 10 miles to the ranch. Well, we just took a virtual road trip from Rawlins to Haley, Wyoming. Few people, even from Wyoming, would consider this drive particularly interesting. But to geoscientists, it is filled with important examples of how our dynamic planet works. We saw how mountains formed by forcing thick blocks of crust one on top of another along thrust belts, like the Rawlins uplift. How mountains collapse, like in the Granite Mountains. How stream drainages evolve as rivers carve out valleys, as at Beaver Divide. And how wind is recorded in the geologic record by sand dunes and how it can be developed as a renewable energy source. We learned about all kinds of different natural resources on which society depends, including industrial minerals, like the Rawlins red hematite ore just north of the town of Rawlins, oil, gas, and uranium at Lost Soldier and Crook's Gap. We also saw an unusual jade deposit at Crook's Gap, jade being a semi-precious gem used in decorative arts. And we learned how technology has revived aging oil fields, such as at Lost Soldier. And all of this in just one 120-mile trek across central Wyoming. Think how much more there is to learn about how the Earth works in this Rocky Mountain state where the rocks are so well exposed. Graduates from the University of Wyoming's Department of Geology and Geophysics work all over the globe. The geologic processes are the same the world over. But they benefited from training in the natural geologic laboratory that is Wyoming. If you'd like to do that too, then I hope you'll get in touch on the department's website. In the meantime, I hope you've enjoyed our trip together reading the rocks in Wyoming's landscape. Thank you very much.